Hello everyone, welcome to my session Set It and Forget It. Today I want to show you how we can use the Cert-Manager to automate the creation and update of TLS certificates in our Kubernetes cluster. This will allow us, once it's set up, to fully automate the entire setup so we don't have to touch it anymore. The plan for today is, first I'm going to give you a quick introduction into the Cert-Manager. Then we talk about Let's Encrypt, which is a non-profit organization which will provide us with the certificates. Then I give you an overview of the domain ownership validation. This is necessary because you have to prove that you own a domain before you can get a certificate. And then we'll spend most of the time in a demo, where I show you how to set up a new Kubernetes cluster and install the Cert-Manager as well as configure HTTPS. Before I get started, a couple sentences about myself. My name is Wolfgang. I'm a freelance cloud architect. I'm based in Toronto, Canada, and I focus on Azure, especially lately on security, governance, and architecture, as well as Kubernetes and DevOps. If you're interested in these topics, you find plenty of videos on my YouTube channels, and if you have any questions, you can always message me on LinkedIn. But now let's get started and let's talk about the Cert-Manager. The Cert-Manager is a free open source tool that will allows you to automatically create and update certificates. This means it creates TLS certificates if it sees we have HTTPS configured in our cluster, and it also updates the certificates before they expire. By default, Let's Encrypt certificates are valid for 90 days, and the Cert-Manager will update them around 30 days before they expire. What's important is that the Cert-Manager is basically the brain of the operations, but it uses an issuer to get the certificate. And the issuer is configured with some authority that provides a certificate. In our case, we will configure it to use Let's Encrypt. This means the Cert-Manager tells the issuer to get a certificate from Let's Encrypt. The Cert-Manager can be used with Ingress and Gateway API. So today I'm going to show you how we use the Gateway API with the Cert-Manager, but I'm not going into any details about the Gateway API. So if you're interested in this, I have a second session where I show you everything you need to know about the Gateway API, but today I want to focus on the Cert-Manager and HTTPS. The Cert-Manager also takes care of helping the certificate provider to verify the ownership of our domain. So we'll talk about it in a minute, but there are two different approaches. Actually, there are three different approaches, but two are very common, so we only talk about these two. And this enables you to fully automate the entire workflow. Before we talk about this, let's have a quick look at the architecture of the Cert-Manager. So as I said, in the middle we have the Cert-Manager, that's the brain of the operation. And then we have one issuer link to the Cert-Manager. And with this, we can configure which company or provider we want to use for our certificates. So there's a whole bunch of provider out there, but we're using Let's Encrypt today. And as you can see here, with Let's Encrypt, we have a staging and a production environment. So that's also something I will talk about in a minute. But basically, the Cert-Manager tells the issuer, go and get me a certificate. Once the certificate is returned, the Cert-Manager will write this in a Kubernetes secret, and then our Ingress or Gateway API will use the secret to verify the HTTPS connection. So now let's talk about Let's Encrypt. That's the most popular and probably easiest to use certificate provider. It's a non-profit organization, and their goal is to make the internet more secure. So if everyone is using HTTPS, we are more secure than if you would use HTTP. What's amazing about Let's Encrypt is it provides the certificates for free. There are some paid services, but basically you don't have to pay for it. For your production environment, everything is free if you want to, and the certificates are valid for 90 days. So there's the idea to have the certificates valid for less and less time. So this time span will be shortened over the next couple of years. And I think the goal is to have it by 28 days, which sounds like a nightmare back in the days when you had to update it automatically. not automatically by hand, but since it's done automatically, it doesn't matter how long they are valid. And the shorter they are valid, the more secure our applications are. So as I said, we have a staging and a production environment, and they are very similar, except there are two distinguished differences. With the staging environment, you have way more lenient rate limits. This means you can register, I think, a couple hundred IPs per day. So it's more than plenty of enough. With productions, I think you can register 5 IPs per week. So if you're trying out how to set it up, it's possible then that you run into this rate limit. So my suggestion is always use the staging environment first. And once you figured out how it works, you can switch over to the production environment. Today I'm going to show you how to do this. So it's very easy, very simple. And the second difference is that the staging environment gives you development certificates. This means you will get a warning in the browser that even though you have a HTTPS connection, you don't have a fully valid certificate. With the production environment, you don't have to worry about this at all. You get a fully valid certificate, and the browser will also accept it and will tell you your connection is secure. So as I just said, with the prod certificates, it's like the ones you paid in the past. It's fully valid in most modern browsers, and you can use it for your production environments. Now let's talk about the domain ownership validation. So you have to verify that you own a domain before you can get a certificate. Otherwise, you could act like somebody you are not. Just imagine if I can get a certificate for google.com, I could pretend to be Google and have all the traffic coming to my website and do some malicious stuff. Therefore, you have to validate it, and there are 3 options we have with Let's Encrypt, but the first 2 options are by far the most common ones, and so I'm going to show you them today. The first one is the HTTP1 challenge, and that's very simple. So, for example, if we take a look here at our cluster or our issuer, then we can see we have a solver. So this is how we want to do the validation. And then we just say it's HTTP1. Then we have 2 different options. So the first one we see here is if we use the gateway API, then we say we have the gateway HTTP route, and we have a reference to the gateway. So here we provide the name and the namespace, and we tell it that it's a gateway. If you're using ingress, then we also have this HTTP1 solver, but here we say ingress, and then we provide our ingress class. In this case, I was using Nginx, therefore I provide the ingress class Nginx. With this HTTP1 challenge, we prove the ownership of the domain with a file. This means the Cert-Manager places a file in a so-called well-known path, and then Let's Encrypt checks if the file is there. If the file is there, then I proved that I own this domain. And this well-known path is your domain / well-known / admin challenge / the ID of the token. This means we create this ID, Let's Encrypt knows about this ID, and therefore we can prove that we own the domain and we get the certificate. What's important is that this cannot be used for wildcard certificates. For wildcard certificates, we have to prove further that we own the domain, and this can be done with a DNS1 challenge. So if we take a look at our issuer, this time we have the solver with DNS1, and in my case, I'm using Azure DNS. And with the DNS1 challenge, we have to write a TXT record into the DNS zone. Here you can see, I will show you later in the demo how to set it up, but I have a reference to my DNS zone. For example, what is the name, what is the resource group where I saved or deployed it, what is the subscription ID, and on the bottom, the managed identity, we can see we can access it through managed identities. This means we don't have to have any secrets or passwords, and therefore we have a secure connection from our Cert-Manager to our DNS zone. All of this is using Entra workload ID. That's basically the managed identities just for Kubernetes. With this implementation, we can prove the ownership of the domain with a DNS record. So as I said, we have the TXT record, we write it into the DNS zone, then Let's Encrypt checks it, and if it's there, it knows I own the DNS zone. The way it works is the TXT record is called _acme challenge dot the domain you want to verify. And what's great about this is you can delegate this challenge to a subdomain. So you don't have to use your main domain. Today in my demo, I'm going to use it, but for example, my domain is programmingwithwolfgang.com, but I could have a subdomain, for example, dnsvalidation.programmingwithwolfgang.com, and only have the DNS challenges inside this DNS zone. This allows me to have my Cert-Manager only have access to this DNS zone, and I don't have anything critical in there. But for now, I think that's already enough of the theory. So now let's take a look at the demo. So the plan for today is I'm going to deploy a complete new cluster. Something I forgot to mention is if you scan the QR code from the beginning, you will see the slides and all the code for the demo today. So you can just easily follow along and you don't have to type anything. But after we have deployed this cluster, I'm going to deploy the Gateway API using Envoy. Then we are deploying the Cert-Manager, and we are going to create a cluster issuer with the HTTP1 challenge. So after we have all this infrastructure set up, we're going to deploy a demo app, and then we try to access this demo app over HTTPS. After we've done this, we're going to create and configure a managed identity. And this managed identity will have access to our DNS zone. Then we're going to update the Cert-Manager to use enter workload identity. And with this, we can have the DNS1 challenge. This means the Cert-Manager uses this managed identity and then writes the TXT record into the DNS zone. After we set up all of this, we're going to take a look at the wildcard certificates and test if we can access our application with that. So now let's switch over to the terminal and let's get started with the demo. All right, here in the terminal, first I'm going to define a whole bunch of variables. So don't be scared, we're gonna use all of them and I will explain them when we use them. First, we have the information for our cluster, like the name, the location, and the resource group. Then we have a whole bunch of variables for our Gateway API. So this is the namespace we want to deploy it, the name of the gateway, what class we're using for it, with different listener. This means we have the HTTP listener, HTTPS listener, wildcard listener, and we also provide the name for the secrets in which we're going to store the certificates. Next up, we have more variables about the Cert-Manager and the cluster issuer. So that's something I haven't managed, but you can have an issuer. So that's a namespace, limited one, or you can have a cluster issuer that's for the entire cluster. So I'm going to use a cluster issuer, and here I provide the name. Then I have the Cert-Manager in my own namespace, and I also provide the name for the managed identity and the service account I want to use. To keep it simple, I use the name Cert-Manager for most of it, because then I take a look at it and I know what it's for. But you can use whatever name you want. Next up, I'm going to configure a couple of variables for my DNS zone. So that's the name of my DNS zone, in what subscription I have it. Then I get the ID of the subscription and also the resource group. So if you follow along with the demo, you obviously have to change this to reflect the values of your DNS zone. And the last couple of variables are for our demo application. So we are going to deploy our demo application in its own namespace. We provide a name, a URL. So this is going to be demo.programmingwithwolfgang.com, and we are going to have a second namespace for our wildcard demo. So now with all these variables out of the way, let's create a new resource group, and I'm going to deploy everything in this resource group. So at the end of the demo, I can just delete the resource group and everything will be gone. Next up, I'm going to create my AKS cluster. And what's important here is I am going to enable the OIDC issuer and I enable workload identity. So both is necessary for the workload identity. This means with the OIDC issuer, Kubernetes sends a token to Entra to this URL of the OIDC issuer. And this will give me an Entra access token. or an Azure Access Token. And therefore, my applications will be able to access the DNS. We'll see all of this once we use it, but for now I'm going to deploy the cluster. It will take around 5 minutes, so I'm going to stop the video here and we'll continue once the cluster has been deployed. Alright, the cluster has been created. Now we just download the credentials and then we can access the cluster. So next up, I'm going to deploy my gateway API. I'm using Envoy for this. So I provide the Helm chart for Envoy. I set the version to 1.7.0. That's the newest version as of recording. And I tell it what namespace to use. So I'm going to create a new namespace and the Envoy controller will be inside this namespace. It should only take a couple seconds for the deployment. And once we have deployed, actually it's already finished. Now we can take a look at the gateway and the gateway class. So as I said, I have a separate session for the gateway API where I tell you all the details. Just a super quick introduction is we have a gateway. So this is where we have all our listeners and we configure what URLs we listen for. Then with the gateway class, that's the link between the controller and the gateway. Therefore, the gateway knows how to process the requests. In our case, it uses the Envoy controller we just deployed, and so the gateway knows what to do. If you take a look at the gateway, we can't see any, and the same for the gateway class, so none of them exist. So we have to create them now. So first, let me create the gateway class. So as we can see here, it's of type gateway class. I provide a name, and here I have a link to the controller. That's the Envoy I just deployed before. Then we're going to apply this. And now we can create our gateway. So let me paste this in the terminal. It's a bit long, but then we take a look at it. So here you can see it's of kind gateway. I provide a name and a namespace where I want to deploy it in. Then what's important is this annotation. Here I provide the name of the cluster issuer. We haven't created yet, so we're going to create it in the next couple steps. But with this annotation, the cluster issuer will monitor the gateway, and if it sees that I'm using HTTPS, it will create a certificate automatically. So I don't have to do anything and I don't have to tell it to create it, so it will be done automatically. After this, we have here our gateway class. So that's the class we just created. And with this, the gateway knows to use the Envoy proxy to process the requests. Lastly, we have listeners. So listeners are the port and the protocol and the host names we want to listen to. So by default, I have one here that's on port 80 for HTTP and allow it from all namespaces. This is important because applications can be in different namespaces and have routes to this application. So that's what we're going to do today. So if the gateway in our gateway namespace and the demo app in the demo app namespace, and thanks to this all, I can accept routes from these other namespaces. Next up, we have one for HTTPS. So here you can see I'm using port 443 HTTPS, and I'm also using my URL. So that's the demo.programwithwolfgang.com. This means my gateway is listening for this on port 443. This means HTTPS. And since we're using HTTPS, we also need a secret where we store our certificate. And before I said that the Cert-Manager and the cluster issuer automatically create the certificates based on the annotation. So this is only half true. It is because of the annotation, but what they do is they check for the secret. So here I have configured a secret, then the Cert-Manager sees no secret exists, which means no certificate exists, and then it creates it for me. Lastly, we have an additional HTTPS listener, this time for the wildcard URL. So this is what we're going to use at the end of the demo. And here I have again the same certificate, or the same configuration, but a different certificate. Also, what we can see here, I have here no namespace provided, and down here I have provided a namespace. But if I don't provide one, it will be created in the same namespace as the gateway, and that's also the same namespace I've configured here. I just wanted to show you that we have the option to use different namespaces. If you use a namespace that's different than the one where the gateway is, then you have to create a reference grant. That's a Kubernetes feature because by default you are not allowed to access secrets from a different namespace. And with this reference grant, you give the gateway access to the secret. But for now, let's keep it as simple as possible. We just have all our TLS secrets in the same namespace as the gateway. So after this, we can apply our gateway. Now I got an error message and I just saw that I have a variable misconfigured. So if you take a look at the wildcard listener name, it just says HTTP listener. And if you take a look at the HTTP listener, it also says HTTP listener. And every name has to be unique. So let's update the variable for the wildcard listener. In this case, I'm using wildcard HTTPS listener. And then we're going to apply or create the gateway again. So this is the same gateway as before, except now with the correct values in the variable. If you apply this, now hopefully it works. So now the gateway has been created. It takes a couple seconds for all the routes to being verified. And since I'm using AKS, I also get a public IP address. To be more precise, my Envoy proxy or gateway controller got the public IP address because it has a service of load balancer, but the gateway also has this public IP address because they are linked together. So if you take a look at it, now we can see I have my gateway. We can see here the name I've provided, the gateway class. Here's the public IP I just mentioned. And what's important is this program is set to true. This means everything is correctly configured and I didn't have any typos or any other problems. If you now take a look at the gateway details, so you can do a kubectl describe of the gateway, then I just saw I'm missing here a variable. Then if you go all the way up, we have quite some information. So we have the configuration of the gateway and also all the events. So for example, here you can see the name and the namespace. Then if we scroll a bit down, we have here our gateway class name. Then we have here all our listener. We have the host names. Then we have here our IP address. So we are going to use this IP address to configure our DNS to point to this IP. Therefore, we'll be able to exit with the demo.programmingwolfgang.com. And we can also see here the gateway has been scheduled by Envoy Gateway. So that's great. We have here it's accepted. But if we scroll a bit further down, it's still accepted and all good. But here we have no valid secret exists. This means we want to use HTTPS, but we don't have the secret with the certificate. This is because we haven't created the Cert-Manager yet. And we can configure the listeners already, but it tells us it's invalid because the certificate is missing. So after we deploy the Cert-Manager and with our certificate, this error message should go away. But everything else is good. So now we can update our DNS. And to do this, let's print the IP address again. So we're just gonna query the IP address. And then I'm going to copy this. So now let's switch over to the Azure portal and update my DNS there. Here in the Azure portal, I have my DNS zone and I've already prepared the DNS records for the demo and also the wildcard.demo. But here I'm using an old IP address. So I'm going to update both of these values with the new IP address we just got. So this should only take a couple seconds. And now both my URLs, the demo.programmingwolfgang and the wildcard.demo.programmingwolfgang is pointing to my gateway. So next up, I can create the Cert-Manager and also the demo application, and then I should be able to exit over HTTPS. So let's switch back to the terminal and let's create both. The order in which we deployed Cert-Manager first or demo application first does not matter, but for now I'm going to deploy the demo app first so we have it out of the way. So I'm just gonna paste everything in here, and now let's take a look at what we're deploying. It's very simple and it basically has nothing to do with the entire setup. It's just an application that serves some request. So we're going to create here a new namespace. Then we have here one deployment with one replica, and I'm using the traffic whoami pod or image. This image provides some basic information. For example, what is the pod name that's running it? If we go further down, we have also here a service, and what's important is we have the type cluster IP, because we want our application only to be accessible through the gateway. Therefore we use cluster IP, and so the application can only be called from within the cluster. Let's save this in a variable and apply the variable. So this should now take a couple seconds for everything to set up, and in the meantime we are going to create our HTTP route. This HTTP route is the link from the gateway to our application. So this basically tells the gateway where to send the request. So here you can see we have the type HTTP route. Then we have a reference to the parent. In this case, that's the gateway. Here we have the name and the namespace of the gateway, and also a section name. So that's the name of the listener. And the HTTPS listener was the one that was listening on port 443 and the URL demo.programwithwolfgang.com. I'm selecting the section name specifically because later I'm going to show you how we can do a redirect from HTTP to HTTPS to always have HTTPS for applications. Therefore, we're going to need this, but all the details in a couple minutes. Next, we configure also here our URL. So that's the demo.programwithwolfgang.com. And under rules, we tell it how to process our requests. Here I keep it as simple as possible, and I just tell it, send all my requests to the service of the demo app. And with this, we send, or we type in the browser the URL, we land at the gateway, then the gateway sends it to the service, and the service sends it to the pods, and the pods serve the application. So now let's apply this. And in the meantime, the application should have been created. So now let's take a look at everything of the namespace. And here you can see we have our service of cluster IP. And we also have up here our one pod running. So that's great. Now we only need the Cert-Manager so we can get the TLS certificates, and then we can access our application over HTTPS. So let me deploy it, and then we're going to take a look at the configuration. So first I'm going to add the Helm chart of the Cert-Manager. As you can see, I already had it before. And then we're going to deploy it. So here I provide its own namespace, and I'm going to create the namespace. Then the version, so that's the newest version as of recording. Since I'm using the Gateway API, I have to tell it with this flag enable Gateway API set to true. And I also enable the CRDs. So that's the custom resource definitions. And these are all the definitions or objects we need for the certificate. So we have a certificate object, we have an order object to order the certificate, or we have a certificate request that's also needed to get the certificate. As you can see, everything is already deployed. So now we have our Cert-Manager, that's the brain, but we also need the cluster issuer. So the cluster issuer will configure what organization or authority are we using for the certificates. So let me paste this first, and then we take a look at it. So here you can see we have the type cluster issuer. This means it's for my entire cluster and not just one namespace. I prefer it this way because it's easier to set up and to manage. Then I provide here the name of the cluster issuer. And if you remember, that's the same I put into the annotation of the gateway. Then we have here two endpoints. But you can see the first one is commented out. So that's the production endpoint. And the second one is the one we're using for now. So that's the staging endpoint. I just want you to see how they differ and how you can switch from staging to production later on. But also in general, it's recommended to always start with the staging server because it has a way higher rate limit. And if you try something out and it goes wrong, you can just recreate it and you don't run into this limit. Once everything works, you can easily switch over to the production server. Then we provide an email. This email will be used for example, update messages if a certificate has been renewed. And then all the way on the bottom, we have here our HTTP resolver. So here tell it I'm using the gateway HTTP route and my parent is the gateway in its namespace and it's of type gateway. So that's all we have to do. And now we can apply this. Now it takes a couple seconds and then the cluster issue sees that there are some secrets at the gateway, but no certificates behind. So it will go and start to order these certificates. And this is done with a certificate request. So you can do a kubectl get certificate request and we can see here we have two. So that's the first one for the demo application. That's called demo let's encrypt because that's the name of the secret. And then the second one is the wildcard let's encrypt secret. And what we can see here, that it says approved is true. This means the request was successfully sent to let's encrypt because that's what we configured. And we can also see here the ready is false. So we have sent the request, but we haven't gotten the certificate yet. If you use a normal URL, this means the demo.programwithwolfgang.com, it takes usually around 30 seconds to get the certificate. With the wildcard one, it's usually around 1.5 minutes because there's more work involved. So if we execute the command again, then we can see our first certificate is now ready. But the second one is still not ready, and this is because we haven't configured the wildcard certificate yet. We have to do the DNS challenge for this, and that's what we're going to do in a later step. But now that we have our certificate, we can do a kubectl get certificate. And there we can see it. We have the certificate and the state is ready. We can do the same for an order. So this is when we order the certificate. And we also have it. The demo let's encrypt is valid. And the wildcard is still pending because we haven't configured it yet. And lastly, we can take a look at the secrets. So here we have our demo let's encrypt secret. And we also have our wildcard secret down here. So all of this has been automatically created. So now we can take a look at the browser, open our URL, and then we should be able to use HTTPS. All right, here in the browser, let's enter HTTPS. That's important. demo.programwithwolfgang.com. Then we get a warning. So now just accept it, and then we take a look at what happened. So you can see I have my host name. So that's the pod of my application. This means I reached my application, but I got the warning here for the HTTPS. So if you take a look at the certificate, it says connection is not secure. And if you open this, then take a look at the certificate. We can see here it's the staging let's encrypt. So this means we got the certificate, but it's not a fully valid production certificate. But this means the entire setup worked. So we were able to access our application over the domain and HTTPS, and we got a certificate. It's just the certificate is not fully valid. So now let's switch back to the terminal and switch the cluster issue from the staging to the production environment. Back in the terminal, let me paste the cluster issue configuration, and it's the entirely same as last time, except here I'm using the production server instead of the staging server. So I'm going to apply this. But if I try now to access my application, I will still get the same error message as before, because the cluster issue checks the certificates and the secrets, and it sees there are some, therefore it doesn't have to create new secrets. So in this case, we have to delete them by hand. So we do a kubectl delete certificate with the name of our certificate. Then I also like to do the same for the order. So that's the name of the order. I just copied from the command before. Actually, seems like it has been automatically deleted. And then lastly, I do the same for the secret. And now the Cert-Manager and the cluster issue sees I want to use HTTPS, but I don't have a certificate, so they will request it now. So it should take only a couple seconds, but if you take a look at the certificate request again, we can see here we have for the demo Let's Encrypt. It's not ready yet, but we can also see here it's 16 seconds ago. So we should only wait probably around 15 seconds longer, and then we should have our production secret or certificate. Let's double check if we have it now, and there you can see now it's set ready equals to true. This means we can now switch over to the browser again, and now we should be able to have a full valid HTTPS connection. Back in the browser, I opened a new incognito window because the browsers like to cache a lot. So for example, it might still tell you your connection is insecure, even though it's secure, it's just something cached. So an entire new window will resolve this problem. I paste my URL again, https demo.programwolfgang.com. And as you can see, this time we didn't get an error message. We have our host name as the pod again. And if you take a look at the connection, it says connection secure. If you take a look at the certificate, it says it's verified by Let's Encrypt. And we can also see here the subject is my URL and the issue is Let's Encrypt. We can also see here it's valid for 90 days. So that's almost 3 months. And everything was done automatically. So we didn't have to set up anything. So that's already amazing. But in a production environment, we often want to use wildcards. And that's what we're going to implement next. So let's switch back to the terminal and implement the DNS challenge and the wildcard certificate. Back in the terminal, for the DNS challenge, we also have to give the Cert-Manager access to our Azure DNS zone, so it can write the TXT record there. This means we have to do a couple steps to set up this permission and this integration. The first thing we have to do is we update the Cert-Manager to use workload identity, or Entra workload identity is the full name. And this will allow us to link our Cert-Manager to a managed identity. And to do this, I do a Helm upgrade. So I have the same information as before. I actually wouldn't need this because the namespace already exists. What's important is this last two parameter. So this is how Entra workload identity works. It works with labels and annotations. So here you can see we set the label workload identity use equals to true. And we also set the label for the service account. And the way it works is that our application has a service account, and the service account will be linked to the managed identity. This managed identity then has the permission on the Azure resource, in our case the Azure DNS zone. So now we update this, should only take a couple seconds, and once this is done, we can take a look at what happened, and we should see the labels in our Cert-Manager. Now the Cert-Manager has been updated. And we can take a look at the labels of the pod with the -l parameter of the kubectl describe pod. So here we see a whole bunch of information, like the pod has been created a couple seconds ago. But if we scroll up, then we can see here we have our Azure Tenant, which has been created automatically. We also have this federated token file and the Azure Authority host. So this means we enabled our Cert-Manager to use Entra workload ID. Next up, we want to create a managed identity. So I just use the AC identity create command. Then I provide a name and the resource group where I want to deploy it in. This should also only take a couple seconds. But after creating the identity, you should wait maybe half a minute because the propagation in Azure sometimes takes a bit. And then if you execute another command with the identity, it might tell you it's not there. So while I was talking, I think this should be enough time. And what we do next is we get the client ID of the managed identity. So we just use an AC identity show with the same parameter we just provided before, and we query the client ID. This is necessary because we need the client ID for the role assignment. So if you take a look at this, we can see we have here our ID. And the next step is to give this managed identities permission in our Azure DNS zone. So here I do an AC role assignment create. I provide the role DNS zone contributor because this managed identity must be able to write into the DNS zone. Then the assignee is the client ID we just queried, and the scope here is my DNS zone. So I provide the name, the resource group, and the subscription it's located in, and query the ID, and then assign it there. This should only take a couple seconds. And once this is done, we've now set up our managed identity. This managed identity has the permissions on the DNS zone, and we've also set up our Cert-Manager to use enter workload ID. Now we just have to link them together. This means we tell our Cert-Manager to use this managed identity to access the DNS zone. And to do this, we have to first get the URL of our OIDC issuer. So OIDC stands for OpenID Connect. That's a standard. And this is what we enabled when we created the cluster. Should only take a second. And if you take a look, we have here our URL. So that's always a mix of the location where you have it deployed and your tenant ID. Now the last step we have to take is we have to create a federated credential. This means we tell it, or actually let's take a look. So we provide a name, then we provide the identity, that's the managed identity we have created before and in what resource group it is. We provide the OIDC issuer, the one we just queried, and here we link our service account from our Cert-Manager to the managed identity. So here we say it's a service account, it's in the Cert-Manager namespace, and it has the Cert-Manager name. And since we provided here the managed identity before, these two will be linked. So when our Cert-Manager now tries to access the Azure DNS zone, it knows that my service account is linked to the managed identity, and therefore it can use the permissions of the managed identity. This enables us to access Azure services without any passwords or secrets. Therefore, nothing can get leaked, nothing can get stolen, and the process is completely secure. Enter workload ID is a completely different topic, and again, I'm going over it quite quickly. But if you're interested, you will find a detailed video on my YouTube channel where you can take a look at it, and I explain step by step how to set it up. So now we've set up everything. Our Cert-Manager has a service account. The service account is linked to the managed identity, and the managed identity has access to the DNS zone. The last step we have to do is update our cluster issuer and enable the DNS1 challenge. So if I paste here the configuration for the cluster issuer, as you can see on top, everything is the same. We also still use the production server, but on the bottom, we have now this DNS1 challenge. Here we provide some basic information about my Azure DNS zone. So that's the name, the resource group, and the ID it's deployed to. And we also provide the ID of the managed identity we use. And with this, the cluster issuer also knows how to access the DNS zone. Then we're going to apply this. And now we can also take a look at the cluster issuer. I think this might help to understand what we just did. So you can do a kubectl get cluster issuer and paste it as a YAML. If you take a look at this, we can see everything we just configured. So we have here the email address. Further up here, somewhere in this wall of text, we have the production URL, or actually it's here, the production URL. Then here we have the HTTP challenge. This means we have the link to our gateway. And down here, we have the DNS challenge. So here, for example, we have the DNS zone and the client ID we used before. Also, what's important is we can see here this message. The Acme account was registered with the Acme server. This means we registered our cluster issue successfully with the Let's Encrypt production server. So you can also see here that the status is true. If something doesn't work and you take a look at this and it says false, then it should also tell you an error message, and this might help you to investigate what's going on. All right, now we configured everything and we should be able to create a test application and then access this test application with a wildcard certificate. So let me paste the code for the demo application. It's again quite a lot of text, but it's basically the same as before, except I deploy it in a new namespace and I provide a new name. Actually, it's the same name as before. I just saw it's just a new namespace. It's again the traffic QMI image, and it's also again a cluster IP service. This means we can only access it over or through the gateway. Then we are going to apply this. And while this is being deployed, we also create our HTTP route. Here you can see it's basically the same HTTP route as we had used before. So again, the type is HTTP route. This time we use the wildcard namespace, but again, we have a reference to the gateway name and namespace. But here we also have a reference to the different listener. So this is the wildcard listener. So the wildcard.demo.programwithwolfgang.com. And what's important here is the host name is also different. Since I'm wanting to have a specific URL for my application, I can't use a wildcard here. I'm just listening for wildcard and then I figure out what do I do with it. So in this case, if my URL is helloworld.demo.programwithwolfgang.com, I send it to this application. To be more specific, I send it to the service of the application. This approach allows me to have one wildcard listener and also one wildcard certificate, but many applications behind it. So for example, I sent the helloworld.demo.programwithwolfgang to the demo app name service, but I could also have, and for example, admin.demo.programwithwolfgang.com to send to a completely different application. But I wouldn't have to change anything in my certificate or into my gateway. So now let's apply this. And in the meantime, our application should have been deployed. So if we do a kubectl get all for our wildcard namespace, then we can see here we have our service of cluster type cluster IP. And we also have here our one pod running. So that's great. And this means we have everything set up. So we can take a look at our gateway. So if I do a kubectl describe gateway, here we can see that the certificates have been successfully created. So around 4 minutes ago was the wildcard certificate. If we scroll up now, then we can see we don't have any invalid anymore. So if here accepted, everything is resolved to true. The listener has been successfully translated. This means we have configured everything correctly. So now you can switch over to the browser and test our demo application. So here in the browser, our URL was helloworld.demo.programwithwolfgang.com. If you open this, we can see we have here our application. We have a secure connection. If we take now a look at the certificate, then we can see it is for wildcard.demo.programwithwolfgang.com, and it's again from Let's Encrypt and valid for 30 days. But this proved that we were able to create the wildcard certificate and also use it. Now let's switch over to the Azure portal and I'm going to show you there what we have created in the terminal. So here in the Azure portal, it's actually quite simple because most of it is running inside the Kubernetes cluster. But what we can see here, we have this new managed identity. And if we open this managed identity, we can see here under federated credentials that we have provided a name. We have the issuer, and here under the subject identifier, we can see it is linked to a service account, and the service account has the name Cert-Manager and is located in the namespace Cert-Manager. Additionally, if you take a look at the Azure role assignment, we can see that this managed identity has one role, that's the one DNS zone contributor, and it is on my DNS zone. If you take a look at the DNS zone now, we can see here there's a new record, the _acme challenge.demo. That's because that's my wildcard URL. And here's the TXT record. So my Cert-Manager created this TXT record in my DNS zone. Then Let's Encrypt checked if this TXT record exists. Since it exists, it gave me the wildcard certificate and I was able to apply it. And all of this was done automatically. And that's why I chose the title of this session, Set It and Forget It. So we configured it once, and if we now deploy 10 more applications, we don't have to configure anything. We just have to provide a host name in the HTTP route. This could be admin, could be another demo, whatever we want. It will generate automatically the certificate or actually reuse the wildcard certificate, and it will work with HTTPS. So for me, that's amazing. Especially the certificate will be automatically updated or renewed before it expires. So it should never happen that you have an expired certificate. The last thing I want to look at is we configured it for port 443. This means HTTPS. But if a user or a client forgets or is too lazy and just writes HTTP or doesn't write anything and the browser assumes it's HTTP, they will get a 404 error because we are not listening on port 80 for our application. And we can easily solve this because we can have a redirect from port 80 to port 443. This means if somebody enters our URL like demo.programmingwolfgang.com with HTTP, it will automatically redirect to port 443. Therefore, the client or customer gets an HTTPS connection, which is secure, plus the application will work. So now let's switch back to the terminal and I'll show you how easy this is to set up with the Gateway API. So back in the terminal for one last time. First, let's take a look what happens if I open my URL with HTTP. Since the browser does a lot of caching and I've opened it a couple times, I would rather use the console this time and I use a curl because I don't have the caching there. So what I do now is a curl with HTTP, that's important, for my URL. So if I send this, I get an error message of 404 because my server is not listening for this URL on port 80. So the solution for this is to create a new HTTP route. So if I paste this one here, we can see here it's HTTP route. Then again, I have a reference to my gateway. But what's important is I have here a reference to the HTTP listener. So if you remember, that's the one that's listening on port 80 for everything. This means my request arrives at this listener. Then I do a redirect to port 443. And then it goes to a different listener because a different listener is listening on port 443 for my URL. And all of this done is down here in the rules. I do a request redirect and I redirect it to HTTPS. And I set the HTTP status code to 301. This means the browser knows I've redirected it. And even though it doesn't have to do anything with the Cert-Manager, but since we have the Cert-Manager in place and HTTPS, I think this is also nice to set up and always have an HTTPS connection. Now let's apply this route and then we can test it again. So we can call our URL again with HTTP and this time we shouldn't get an error message. So if we call this, we can see here we reached our application. We have here the host name, so some information. We have the HTTP 200 status code, but we don't see here that we did a redirect. So if you use the same command in a Linux environment, you should also see the redirect. But we have seen we got an error message before, and now we see the content. This means it works and we were able to exit our application. This brings us to the end of the session. So today we have seen that it is very easy to set up the Cert-Manager and configure it to create certificates automatically for your application. So I showed you how to use the staging environment first to get started and make sure everything is working. Then we switched over to the production environment and got fully production ready certificates for our browser. And we also had specific URLs configured. After this, we used Enter Workload ID, an Azure feature that allows us to link the Cert-Manager to a managed identity and this managed identity to the Azure DNS zone. And with this setup, we were able to create the TXT record that's necessary for the validation of the wildcard certificate. This setup also allowed us to have a secure implementation. This means we didn't have any password or secrets. And once it's set up, we don't have to worry about it in the future anymore. If we deploy more applications now, they will just have each TLS certificate and can use HTTPS. I hope this session was interesting and useful for you. If you're interested in the slides and all the code I showed you today, you can scan the QR code and you will find everything there. I wish you a great conference and many interesting sessions.